Hello, I'm Saranya Kesavan. I'm doing my master's in the Department of Spatial Information Science and Engineering at the University of Maine. I'm working under Dr. Nicholas Giudici in his Virtual Environment and Multimodal Interaction Lab. One of the key interests of our lab is to generate indoor scene descriptions from visual images. In order to help you understand better about this research, think of yourself in the following situation. That is, assume that you are blindfolded and you are standing at the door of a new indoor space like a hotel lobby or a doctor's office. If you want to navigate in that room, either you should be able to view that room or you should have known about the room, its orientation, the objects in the room, and their relative positions. In short, you need to have a mental map of that room. As you are blindfolded, you cannot see, and the main aim of this research is to provide you with information that is essential to develop a mental map through a natural language description of that space. So this research concentrates on navigation assistance for low vision people. Consider the previous example in which you needed a cognitive map. Imagine that you have a cell phone equipped with a camera and you're taking random photos of that indoor space, and after a brief moment your cell phone gives the description of that indoor space. For example, it says that the table is ahead of you in about 3 feet at 11 o'clock, or a bookshelf is to your right in about 4 feet at 3 o'clock. So this research is carried out by different teams in order to identify the objects in an image using computer vision to create ontologies of indoor spaces, and my research interest is to create the natural language description of those ontological relationships. So this description can be used to build up a mental representation which supports spatial behaviors. The main challenge in natural language description is to avoid the usage of ambiguous language. In order to avoid that ambiguity, we have to understand the semantics of the natural language. So understanding semantics includes an understanding of spatial relationships and representing them using spatial prepositions like near, on, above, etc. So what is the problem with spatial prepositions? Let me explain that. See this image. We can see that the alarm clock is near the computer. Even now, we can say that the alarm clock is near the computer. But now, we can't say that the alarm clock is near the computer because the ball is near the computer. So what does the preposition near means in the description of a relationship between two objects? So one of my research interests is to quantify the spatial prepositions used in natural language descriptions. In this office scene, if we want to describe the relationship between the bookshelf and the table, we can say that the table is near the bookshelf. Here we use bookshelf as the base object and the table as the target object. But if we want to describe the relationship between the chair and the table, we'll say that the chair is near the table. Here table becomes the base object and the chair is the target object. In order to develop the natural language description of an indoor space, we should use the appropriate target and base objects while forming a clear relationship between those two objects. So understanding the qualifiers for categorizing the target and base objects is also a part of my research. So once we understand the nature of spatial relationships and their representation, the next step is to apply them in developing a mental map of that indoor space and assist the user with a navigation guidance system. With this description of guidance system and spatial representation, we can prepare a description template of a sample space. When we are creating the description template, the other teams will be creating an instantiated ontology for the same sample indoor space. Now my research interest will be to apply the learned semantics in those instantiated ontologies and to create a natural language description that supports spatial learning and behavior. Consider this real-time example application in which the user asks the system to find an empty chair in a hotel lobby. As a result of image detection and ontological approaches, we'll have an instantiated ontology of that indoor space as shown here. Now applying the learned semantics to this ontological response will automatically describe the position of an empty chair using natural language. So helping the low vision users by providing them with a navigation guidance using natural language by creating a mental map of that indoor space is my research interest. For information about this research, please contact me at saranya.kesavan@maine.edu. Thank you.